Hello, eighth graders. Today you need a blank piece of graph paper. You need to take that graph paper and you need to fold it in half horizontally this way. What we are practicing today is we are working on writing all the different forms for a linear situation. If I give you one, can you come up with the rest of them? So in this top box here, will you please write number 1? Like so. And then I am going to give you a context, which of course we know means a story. And it's on this laminated card here. So I'll try to get it to where the light is. I'll just read it to you. It says, you are taking a road trip. You start the day with a full tank of gas. Your tank holds, oh my goodness, that says context too. Well, there's a preview of what's coming next. Let's start with this one, the one that actually says number 1. You and your friends go to the state fair. It costs $6 to get into the fair and $2 each time you go on a ride. Consider the relationship between number of rides and total cost. That last sentence right there is going to help me create a table. Okay, so here I go. I'm going to go, I don't need a ton of space, but I'm just going to make a T-chart here. And I'm going to put, all right, I'm going to consider the relationship between number of rides. So I'm going to put rides over here and total cost. Okay, so let's say you go to this state fair and let's say that you don't ride any rides. You're just going maybe to hang out with your friends or I don't know why you're going if you're not riding any rides, but let's say you go in and you don't ride any. Remember, our true starting point in mathematics is always 0. So I'm going to fill in this independent events side. There's no set number that I need, but I want enough to be able to see what's going on. So I just put 0, 1, 2, 3, and 4. If you just go to the fair and you don't ride any rides, it's still going to cost you $6 just to get in. And then every ride you ride after that is $2 more. So we are going to have a constant adding pattern of $2 per ride. This is a linear relationship, so it makes perfect sense that we have a constant adding pattern of $2 per ride. So what you just did is you just took a linear context, a story that is a linear situation, and you turned it into a table. There's one of our representations. We have a context, we have a table. The next representation we're going to turn this into is a graph. So the graph is going to, I need it to go up a decent amount so that I can see what's going on. I could also change the scale and make it go by 2s if I wanted to. I'm going to let this one go by 1s and then we'll change it on the second one and see. So I am going to make sure I have plenty of space. So I just came over here. And then I'll draw this way. I left a couple of squares before I didn't go all the way down to the fold because I need some room for labels. So this down here is going to be number of rides. And I'm going to label this 1, 2, 3, 4, 5, 6. That's good enough, I think. And then over here, this is going to be total cost. And I made enough room that this can go by 1s as well, but you know what? I don't really want to label every single one of them. So I'm just going to go, this would be 1, 2, 3, 4, 5, 6, 7, 8. See how I really am counting by 1s? I'm just not labeling every single one because that can get a little tedious. And frankly, I don't need to see every single one to know that they're going by 1s. Let's take this information and turn it into a graph. So at 0 rides, it will cost $6. After that, every ride you go on is $2 more. So up to over 1, up to over 1, up to over 1, up to over 1. And we can use those slope patterns to actually get more in the graph than we even had in the table. That is the benefit of multiple representations. So here we go. There's that up there. All right. Now, what's the other representation? Remember, we wrote them on our notes yesterday. We have a graph. We started with a story, then we made a table, then we made a graph. And what else do we have? We have an equation. Now we are going to turn this situation into an equation. This is linear, so it's going to fit y equals mx plus b. What is m? M is our rate of change, which was $2 per ride. And what is b? Our starting cost of $6. So the equation that represents this situation is y equals 2x plus 6. The next thing and last thing you're going to do is just answer a couple questions about this situation. So for these first couple, you're going to write them down with me. The first question I'm going to ask you is, how much does 25 rides cost? Now, if I ask you a question like how much does 25 rides cost, we can look at the two representations, all these representations we have, and we can decide which one makes the most sense to help us answer this question. 25 rides, I guess I could get it from my graph, but I'd have to extend this x-axis all the way out to 25 rides. I don't really want to do that. I could also get it from my table, but again, I would have to take this table all the way down to 25 rides. And once again, I don't really want to do that either. And this is why we write rules in mathematics, because they are often the most efficient way to get what you're looking for. So here, how much does 25 rides cost? Well, rides is the x. So I'm going to plug it in for x. 2 times 25 plus 6. 2 times 25 is 50 plus 6. How much would it cost? $56. 25 rides. One more question, part B. What if instead of asking you, how much will it cost to ride a certain amount of rides? What if you know how much money you're going there with? Let's say if you have $100. So now I'm telling you the dollar amount that you have. And the question I'm going to ask you is, how many rides can you ride? Now, once again, $100 is too far to find on my graph and too far to find in my table. That's okay. I like the equation best anyway. So I'm going to plug in $100 for my y value now. How come I'm going to do that? Because dollars is on the y-axis. So here we go. Y is 100. 100 equals 2x plus 6. Wait, what am I doing here? Oh, I'm going to use inverse operations now to solve for x. So I'm going to go minus 6 on both sides. 100 minus 6 is 94. And now I divide by 2. See, I'm just using inverse operations. And 94 divided by 2 is 47 rides. Do you see how I just used that equation to find both ways, really? To find if I gave you the rides, you could find the dollars. And if I gave you the dollars, you could find the rides. All right, one more story. Here we go, number 2. And you already saw a preview of it. Number 2. This is the one about a road trip. And you start the day with a full tank of gas, and then it says your tank holds 16 gallons of gas. Okay, so if your tank is full, right now you have 16 gallons of gas. That sounds like a starting point to me. On your trip, you use 2 gallons of gas per hour. That sounds like a rate of change. Here we go. Consider the relationship between time and hours. Ooh, this is making me ready to make a table. So here I go. Time and hours. H is for hours. And the amount of gas remaining. I'm going to put gallons left. That means gallons left in your tank. Okay. At time 0, you had 16 gallons. That was your starting point. That's what you started with. Your tank was full. At time 1 hour, 2 hours, 3 hours, what's happening in this story? Oh, you're using 2 gallons per hour. This is a negative rate of change. You are losing 2 gallons every hour. Okay, we just turned that linear context into a table. Now let's turn it into a graph. This time, instead of doing this big giant thing that fits all the ones that I need, what if I make it a little bit smaller and then I just change my scale? And what if instead of going 1, 2, 3, 4, 5, 6, 7, what if I let every box equal 2, just so I don't have to draw quite as much? So this is going to be hours. This will be 1, 2, 3, 4, 5, 6. And then over here, this is going to be gallons remaining. And since I didn't do a big, long, tall thing, I'm going to say this is 0 and then 2, 4, 6, 8, 10, 12, 14, 16, 18. Now I just let every box equal 2, which is totally fine and totally allowed. Just make sure you keep track of that as you work. Okay, so what did I start with? 16 gallons. And then every hour, I lost 2, down 2 over 1. So this is really down 2 because I let every box be worth 2. So I just turned, I'm just going to keep going there. I just turned that table into a graph. And actually, I didn't even necessarily need the table. I turned one linear story. I'm turning it into a table and then a graph. Now, what else do we need? We need an equation. Here I go. Y equals negative 2x this time. We had a negative rate of change because we were dropping 2 gallons every hour, plus the 16 that we started with. Okay, and now I'm going to ask you a couple questions about this. Part A, how many gallons do you have left after 3 hours? Well, let's go ahead and use our equation just like we did before. If I give you hours, hours is on the x-axis. Y equals negative 2 times 3 plus 16. Negative 2 times 3 is negative 6 plus 16 is 10 gallons. Now, by the way, did I really need the equation for that one? Probably not. Because look, it's right here in the table, 3 hours, 10 gallons. It's right here in the graph, 3 hours, 10 gallons. But the point is all of these representations are showing the exact same relationship. So you should be able to find it and come up with the same thing no matter which one you use. Okay, one more question. Part B, how long? Changing it up a little bit. How long have you been driving? How long have you been driving? If you have 2.5 gallons left. This is another place where using the equation is helpful because 2.5 is not in the table. I could maybe figure it out. And it is in the graph technically, but it's kind of hard to read because it's not in a nice even corner. So if they give me gallons, I'm going to plug that in for Y. 2.5 equals negative 2x plus 16. And I'm going to solve this for x. Minus 16 from both sides. 2.5 minus 16 is negative 13.5, which seems weird at first. You're like, I just got a negative. But that's okay because you're going to divide by a negative right here, and that is going to turn it back into a positive. 13.5 divided by 2 is 6.75 hours, which is why we couldn't read it exactly clearly on the graph, which, by the way, 0.75 hours is 3/4 of an hour, which is 45 minutes. Okay, here's what you're going to do now. Flip your paper over. You're going to write number 3 on the top half here. And then you're going to write number 4 on the bottom half here. And you are going to try 2 more situations. Here's what's going to be different about these. When you scroll down after you're done watching this video, when you scroll down in Canvas, you're going to see that I'm actually going to start you with some tables. That's actually one less thing for you to do. On this side, we had to do a table and a graph and an equation. If I start you with a table, you are just going to turn it into a graph and then write the equation. And then there will be 2 questions for you to answer. And it's all typed into Canvas, so take a look. Try those last 2, writing different representations of linear. If you have any questions, ask your math teacher. Good luck, you've got this.